Hello, Algebra 1B students. Welcome to part 2 of lesson 10.3 on our math operations with square roots or with radicals. Today, we're going to multiply with square roots, including some foiling with square roots involved. And most of our problems are going to ask us to simplify a given expression with square roots and numbers added together or something like that. Simplify in this case means combining all of the like terms. Remember that like terms in the case of square roots means square roots with the same number underneath. And then they'll also ask us to get rid of all of the parentheses. So we want no parentheses, and we want to combine all of the like terms that we can. Right? What this looks like is something like this. The square root of 10 times, in parentheses, the square root of 6 plus the square root of 3. Now, we're going to use the distributive property in this case, and then try to simplify as much as we can. So if we are being asked to simplify this expression here, I'm going to distribute the square root of 10 to both the square root of 6 and to 3. So what I end up with is the square root of 10 times the square root of 6 plus the square root of 10 times 3. Now I know that the square root of 10 times the square root of 6 is the square root of 10 times 6, which is 60. And then I will just flip the order of the other two terms, 3 times the square root of 10. Now, there is no perfect square number that goes into 10, so I will leave that the way it is. However, there is a perfect square number that goes into 60, and that is 4. So I'm going to simplify now this term here, the square root of 60, by saying that's the square root of 4 times the square root of 15. And I know that the square root of 4 is 2. Plus, 2 times the square root of 15. I can't forget that part. Plus 3 times the square root of 10. Now I have the square root of 15 and the square root of 10. Again, I don't think any perfect square numbers go in there, so I have to leave those the way they are. And since 15 and 10 are not the same number under those square roots, I'm done. Right there is the most simple form of that expression that I can get. So notice that I have no parentheses in my answer, and that I have combined all the terms that I can. Unfortunately, it turns out that I don't have any like terms that I get to combine there. Right? So that's what it looks like to use the distributive property on some square roots. You'll have to multiply and then simplify whatever you can to try to combine things. You may also be asked to do FOIL with some square roots, and that's what letter B here is asking us to do. We have the square root of 6 minus 2 square roots of 3, all of that in parentheses times 6 plus square root of 6 plus the square root of 3 in parentheses. So I'll start by doing first, that is the square root of 6 times the square root of 6. Outside is a plus square root of 6 times square root of 3. Inside is actually a minus 2 square root of 3 times square root of 6. And then last is also a minus 2 square root of 3 square root of 3. And all this is multiplication. So that's what I get when I FOIL, and now my job is to take each piece of this and simplify it as much as I can and see what I can combine. I will start on the far left with the square root of 6 times the square root of 6. That is the square root of 36. Because I can just put both of those 6's under a square root, multiply them together. Okay. The same thing in the second one, that's the square root of 18. Then the third term, I have 2 times a square root that I can put together. That's 18 as well. And then here I have 2 times the square root of 9. So let me give myself some more room here. And then combine the terms that I can combine, simplify the terms that I can simplify. My farthest left term is the square root of 36. I know that the square root of 36 is 6. Next I have 1 square root of 18 minus 2 square roots of 18. So notice please that there's a 1 there. And now if I put together these 2 middle terms, 1 square root of 18 minus 2 square roots of 18, I actually end up with 1 minus 2 being a negative 1 square root of 18, or just a negative square root of 18. And then at the end, 2 times the square root of 9, 2 times the square root of 9 is a minus 2 times 3. Okay, so I'm going to finally simplify this by saying 2 times 3, that's really 6. So I now have 2 numbers that are not under a square root, 6 and a minus 6. Well, those cancel each other out. Those are gone. And all I'm left with is a negative square root of 18. But I can simplify the square root of 18 by separating that into the square root of 9 and the square root of 2. And that equals negative 3 square roots of 2. So a long process after I FOIL of putting pieces together, simplifying multiple square roots, and I end up with something that's relatively nice. Negative 3 times the square root of 2. Because my 6's went away, and that's what my square root simplified down to. Okay? I would like you to try this by simplifying this expression here. The square root of 7 plus the square root of 3 times the square root of 7 minus the square root of 3. Do a FOIL, simplify all the square roots that you can, and see what you get. Pause the video, take a look at that, then come on back, and I will show you the correct answer. All right, when we FOIL, the square root of 7 times the square root of 7 ends up being the square root of 49. The outside ends up being minus the square root of 21. The inside ends up being plus the square root of 21. So those will cancel each other out too, that's nice. And the last is minus the square root of 9. Okay, so the square root of 49 is 7. This is all gone. And it's minus the square root of 9, which is 3, so my final answer is 4. Again, because of the minus there, I don't have to worry about plus or minus. So I just end up with 4. That worked out very, very nicely when I FOILed out those 2 expressions, those 2 pieces. I ended up with just 4. No square roots, no plusing, no minusing, just a 4. Now, that is called conjugates. When you have the same 2 terms, like the square root of 7 and the square root of 3, one is adding and one is subtracting. Those 2 pieces are called conjugates. Conjugates are the sum and difference of the same 2 terms. And what they want you to notice is that when you FOIL them out, when you multiply them together, you get no square roots, no radicals, as your book says. So we can use conjugates to rationalize the denominator of a fraction and get rid of all kinds of crazy square roots in the bottom of a fraction. Let me show you what that looks like. It looks like this, simplifying 10 over the square root of 7 minus the square root of 2. Okay? Now my goal here is to get all of the square roots out of the bottom of that fraction. I do not want it to be there, and I don't want any of them to be there. So the only way to get rid of both of those square roots at the same time and not have any in my answer is to multiply by the conjugate. So that's what I'm going to do. I'm going to multiply by the conjugate on the top and the bottom. As a reminder, the conjugate is exactly the same two terms, but the opposite sign. So because this one is a minus, I need to multiply by a plus. So it's the square root of 7 plus the square root of 2 on both the top and the bottom. Now, I'm going to leave the top kind of alone and deal with the bottom first, but I will tell you that the top of my fraction is now 10 times all of that square root stuff in parentheses. Square root of 7 plus square root of 2. Okay, and now the bottom is going to become, well, it's another FOIL. First is 7 times 7 square root of 49. Square root of 49. The outside is a positive square root of 14. The inside is a minus square root of 14. So those cancel each other out. I don't have to worry about those. That's the whole point of me multiplying by the conjugate, is that those middle square roots cancel each other out. And then the last is a minus square root of 4. Okay, now I'm going to leave the top alone again. 10 square root of 7 plus square root of 2. Now the square root of 49 is 7, and the square root of 4 is 2. So it's 7 minus 2. I end up with here 10 square root of 7 plus square root of 2 over 7 minus 2, which is 5. So I've now accomplished getting rid of all my square roots, but I can do more, because I want you to notice that on the top here is a 10, and on the bottom here is a 5. So I'll cancel that out to be a 1 and a 2, and my final answer is 2 square root of 7 plus 2 square root of 2, because I need to then distribute my 2 to get rid of all the parentheses. That's what I end up with. Because the bottom of my fraction went away, it became a 1. I don't need it anymore. The top of my fraction is 2 times those 2 square roots in parentheses, so I distribute the 2, and I have my final answer right there. Now, if you have questions about what I just did, make a note to ask me in class, or go back and rewatch my process of multiplying by the conjugate. Then I would like you to try this one yourself, finding the simplified form of negative 3 over 10 plus square root of 10 plus square root of 5, and see what you can cancel out maybe at the end. So pause the video, take a look at that problem, then come on back and I will show you what we should get as our answer. Okay, when you multiply the top, you should get this. And we'll leave that alone for a second. The bottom becomes the square root of 100, which is 10, plus the square root of 25, which is 5. So 10 plus 5 gives me 15. And now I can cancel the 3 and the 15. That becomes a 1. This becomes a 5. So I end up with negative 1 parentheses square root of 10 plus square root of 5 over 5. And then if I just simplify one more step, distributing the negative 1, that equals negative square root of 10 minus the square root of 5 over 5. That one does have a fraction because the denominator of my fraction did not disappear as it did before. If you have questions about anything, please make a note to ask me in class tomorrow while you are working on practice problems. That's all I have for you right now. Have a wonderful night.